Today's video will follow the experimental setup section of the 420A user guide. We're going to follow the daily procedures for setting up the system for experimentation, dissection and mounting of a mouse mesenteric artery, the wake-up protocol including normalization, and a few agonist responses. If the system was cleaned from the day before, all you need to do to prepare the setup for experimentation is fill both chambers with cold PSS buffer. For today's purposes, we will be using a mouse mesenteric artery. The mesentery is a good tissue bed for practice as there are many vessels and the vessels are fairly easily isolated. You should pin out the mesentery so you can easily see the different vessels. Begin by cleaning away the excess tissue. If you are unsure which vessel is the artery and which is the vein, you should be very careful with both until you can make the determination. It is very important to identify the artery. The artery will have thicker walls, which will make the vessel appear more white. It will have a smaller lumen because of the thick walls, and the vein will appear more red. It may be tough to tell on the black and white video, but the vessel on the right has thicker, wider walls, where the vessel on the left is the vein, and you can see it has very thin walls. You should be as careful as possible with the artery while dissection. You should avoid touching the artery with your forceps or nicking it with your scissors when cleaning. Add as little stress as possible to the vessel for the best results. Once you have identified the artery, you can then cut away the vein. After removing the vein, you should then continue cleaning the artery. Again, be careful as possible when cleaning. Try to only hold on to the excess tissue, which you will cut away. Once you have cleaned the artery, you can then cut it away from the rest of the tissue. You can use a small plastic ruler in your dissection dish to help estimate the tissue length. As you can see, this vessel is 5 millimeters, so we will cut this vessel in half. We are now ready to begin mounting the artery on the 420A chamber. You will first secure a section of wire between the jaws. Be sure not to clamp too hard on the wire. You just want to hold it in place. You can then secure the back end around one of the screws. It does not matter which side, but the user guide does recommend starting on the transducer. Be sure that your wire goes clockwise around the screw. You can then transfer the artery into the bath. Fix your view on the free end of the wire and begin to mount your vessel. The vessel may have been clamped closed when cut with the scissors. Be cautious when pulling it onto the wire and when opening the back end. You want to limit the handling as much as possible. Once you have the vessel in place on the wire, you can then slide it to the jaws. Open the jaws and let the wire come free. You can then slide your vessel in the gap of the jaw. You can then secure the second side of the first wire. Again, make sure that you are going clockwise around the screw. With the first side secure, you can then introduce the second wire. After securing the first wire, you should make sure that there's no tissue that extends beyond the space where the jaws separate. Move the jaws apart and hold the second wire approximately 10 millimeters from the tip. Insert the second wire. Avoid touching the lumen as much as possible or letting go of the wire while it's still inserted in the vessel. Make sure that it is all the way through or remove and reset. You may want to add a small bend in the back half of the second wire. This will help when introducing it through the vessel. As the back end of the wire touches the chamber, it could make the tip move. After getting the second wire inserted, you should pull the other end through the vessel and make sure that it is equal distance on both sides. Once the wire has equal sections on both sides of the jaws, you can then close the micrometer side At this point, you can secure one end of the wire. You should separate the jaws very slightly to allow free movement of the wire. Pull the remaining end taut and secure the remaining side. When you are finished, make sure that both of your wires are tight and secure. If you have a loose wire, this will affect the normalization and will dampen the forces that are recorded from your tissue. Make sure that all wires are taut and at the same height. You want to make sure that your wires are as close as possible without touching before taking the chamber back to the interface. After mounting both of your vessels, you can bring the chamber back to the system. Plug in the chamber with the myograph cable, begin bubbling, turn on heat, and exchange the buffer in the bath. You can then start the experiment, and you should wait 20 minutes while the tissue warms up and sits at the new temperature. After 20 minutes has passed, it is time to do the normalization. This is an extremely vital step, and if not done properly, the rest of the data from the experiment could be invalid. Experiments with elastic properties, like the vessels and especially arteries, can only have meaning if performed under conditions where the size is clearly defined. The normalization has an effect on the sensitivity to agonists, so a standardized approach is vital. Active responses are dependent on the extent of the stretch of the smooth muscle cells, so you must set the vessel to an internal circumference to give the maximum response. There are multiple ways to do the normalization, but today we will follow the DMT normalization module. First, we must go to the DMT menu and select normalization settings. We will use an eyepiece calibration of 1 since we know the lengths of the vessel. The target pressure is correct, and in this case, the IC1 to IC100 value for a mouse mesenteric vessel is 1. We can leave the rest the same. This IC1 to IC100 value and the target pressure will be dependent on the specific vessels you are using. We will now go in to do the specific normalization for each channel. So we can open channel 1 and open channel 2. For more detailed information and explanations on the normalization procedure or help reading the micrometer, please refer to the DMT normalization guide found on the website. We must now enter our tissue endpoints. So we will put in 0 for the first point, and this vessel was 1.7 millimeters. We used a wire of 40 microns, and our first micrometer reading for the near channel is 5330. This will take 60 seconds to take a reading, so in the meantime, we can do channel 2. Again, our tissue endpoint is 0, and in this case 1.9. We used 40 micron wire. And our micrometer reading here was 5170. Again, we have 60 seconds to take a reading. We will continue the normalization and adding points as we stretch the tissue with the micrometer until we cross our target pressure line. We do not want to go too far over, as this is overstretching our tissue. But while you are far away from crossing the line, you can still add steps of 40 to 50 microns at a time. After you get 3 readings added, you will then see your line of best fit, which will help you estimate where you are in the normalization process. Both of the channels are very close to crossing the target pressure line. Once this is done, you will have a micrometer reading where you should set the micrometer for each channel. This is the micrometer reading that should give you the best results for your tissue. Both curves have crossed the target pressure line. On channel 1, it is suggesting that the micrometer should be set back approximately 12 microns, and channel 2 should be adjusted back around 10 microns. We will physically make these changes to the micrometer on the chamber. This is a good spot to zero the transducers and exchange the buffer in your chamber. You then need to let your vessels sit at their new stretched position for 20 minutes. We will now start the wake-up protocol, otherwise known as the standard start protocol. The purpose of running this section is to reactivate the mechanical and functional properties of the vessel segment. We want to check that the responses to different types of stimuli are normal in appearance, and thereby ensuring that the functionality of the vessel segment has not been damaged during the dissection or the mounting procedures. The first step after normalization is exposure to KPSS. We will replace the bath with 60 millimolar KPSS for an exposure of 3 minutes. Follow the exposure to KPSS with a series of washouts over 5 minutes using regular PSS. After 5 minutes of washouts, we will repeat our exposure to KPSS for 3 more minutes. After this exposure to KPSS, you can repeat the 3 washouts over 5 minutes before continuing. We will now add 10 micromolar phenylephrine to the baths. After 2 to 3 minutes, you should reach a plateau where you can add the acetylcholine. We can now add the 10 micromolar ACH to the bath. You can see that the vessel in the near chamber has responded much better to the KPSS, phenylephrine, and acetylcholine. The second vessel did show some responses, but they were diminished compared to the other vessel. You should now perform at least 5 washouts over 15 to 30 minutes until your vessels return to baseline. After this, you are ready to start the experiment. For more information, please refer to the 420A user manual or additional resource videos found on the DMT website.